Everyone, welcome to the channel. And today you will see NDVI anomaly time series plot in Google Earth Engine. So let's get started. So before that, let's import some more point data. So to import a point data, we define a variable called point geometry.point. So this refers to the latitude and longitude. After that, we define a country's boundary, and after select the the particular study area. So for that, I defined a variable called countries equals to feature collection US DOS United States of Department of State large scale international boundary polygon 2017. To import the world level country boundary polygon into Earth Engine, we had to define a variable called countries equals to and specify this code in order to import the world level country boundaries. So next is we define a variable called Ethiopia, that is our study area. So equals to countries dot filter dot filter dot eq country na output as output layer name as Ethiopia. So from a large scale international boundary polygon, that is our world level country boundary polygon, we are selecting specifically Ethiopia as our study area. So next we're going to import our modus image, that is NDVI modus image. So modus has several bands. In that particularly we are importing the NDVI one. So to import that modus NDVI band into Earth Engine, I have defined a variable called variable modus NDVI equals to w.image collection modus MCD4 3A4 NDVI, that is normalized difference vegetation index. So to calculate the mean, we define a variable called mean equals to w.image collection w.list sequence. So we are sequence from 1 to 12, referring from January to December. So before that, we want to calculate our monthly NDVI anomaly. So we could like to perform an NDVI anomaly analysis from multiple years. So for that, so to do that, we need to calculate. So we need to calculate the long-term mean. So long-term mean for each month. So basically, I will call that as a variable mean. So for every month, the January, the long-term NDVI mean value, the long-term mean value, mean NDVI value for multiple years. So I will use that data to subtract with each month to generate the monthly NDVI anomaly. So for that, I have defined a variable called where variable mean equals to image collection list sequence from January to December from 1 to 12. Map function m refers to months and return mode is ndvi.filter filter calendar range. So the return here refers to our variable modus, that is variable modus ndvi, that is our image we have imported into our Earth Engine. So we are filtering it with our calendar range. So we are filtering it with our calendar range, but that is with our month and output as month. And we're calculating the mean value for each mean NDVI value for each month and set as a month. So for example, if you have a 10 years of data for the month of January, so we can compute the long-term mean value of the month January for multiple for the period of 10 years. So this function is technically does is calculates the mean value of the long-term NDVI mean value for each month. So next is we define a variable called start. So we are selecting with the particular time that is from 2012 January 1. So we have defined a start time as a variable start equals to w.date 2012 January 1, and the variable month equals to w.list sequence from 0 to 36. 36 refers to the months, so we are starting from 2012 to up to 3 years of data. So for that we have defined for list sequences from 0 to 36. So it will take a data from 2012, 13 and 14. So next is we defined a variable called dates equals to months dot map function index return start dot advance index output as month. So basically, what it does is starts this sequence from one to from January to December. So technically, what it does is it starts from the variable from 0 to 36. So that is a sequence from 0 to 36 refers to 3 years of the 3 years of timeline, 3 years of data from 2012 to 2013 14. So for that we define from a variable date month dot map. So month refers to this variable this month. So we are given a sequence called this sequence from 0 to 36. The dot map function index. So return start in advance index and output as a month. So it gives us the data from 2012, 13 and 14. So next is we're going to see group by month and then reduce within the group by mean. And the result is an image collection with one image for each month. So this function and what it does is, so what it does calculate is that it calculates the mean value of each month for the time series from 2012 to 2014. So this is where we calculate our anomaly, where we subtract the return mean, we subtract. So we calculate we subtract the each of the monthly mean value minus of the long-term mean value. So the mean here refers to our long-term mean value. So this is our long-term mean value. So technically, what we are doing is, so we will calculate the mean monthly. So and we subtract the mean monthly by the long-term mean value. That is this one I have shown here. This is our long-term mean value. So we are subtracting our monthly mean value. So that is our monthly mean value minus I'm subtracting with the long-term mean value. So we will subtract our long-term mean value by our monthly mean value. So which will give us a monthly our monthly anomaly. So which will gives us a monthly anomaly. So basically we are doing that we are using the long-term mean value minusing we are subtracting with our monthly mean value to derive the monthly anomaly NDVI value. So technically this will generate our monthly anomaly data. So next is we're going to add our layer into Earth Engine. So that is to add the layer, we define the map.add layer w.image. So by month refers to this value, that is our monthly anomaly data, and dot first refers to that is our first layer. So dot clip, we are clipping with our study area, that is our Ethiopia. So that is we are filtering. That is basically we are clipping by our study area Ethiopia with a minimum value of minus 0.3 and a maximum value of 0.3. And we have chosen the sequence of the color palettes, the colors for our layer that is defined by a palette. So we define the sequence of color for our layers and output as that is our and we output as an NDVI anomaly. That is we giving a layer name as NDVI anomaly. And next we are centering to center our layer. We define the map.center object and referring to our study area, that is Ethiopia, with a zoom level of 6. The next is to chart our NDVI anomaly. I have defined a variable called variable chart equals to ui.chart.image.series. So this is a specific code we use to plot our NDVI anomaly value as a chart. So for that we define the image collection. Equal image collection we define by months. That is by month. So now let us run our code. Go to the option called run script. Click run script. So now you can able to see that we have our layers being loading. So technically what we are loading is, so basically we are given a code for adding our image, that is add layer by image by month dot first. So first refers to this first refers to this time series, that is the 2012 January 1. So basically what we are seeing is this is the NDVI anomaly of 2012 January 1. So because we are selected users with our code dot w dot image by month dot first. So it refers to 2012 January 1. So this map is of NDVI anomaly of 2012 January 1. That is 2012 January data anomaly. Now we can able to inspect this anomaly data. So you can inspect it by using to go to the option called inspect, and now you can able to click here. So now you can able to view that we have our NDVI value in positive sign, that indicates our higher vegetation, that is our vegetation index. So basically we have our NDVI value is higher NDVI value in this region, the greener portion of the study region, that is our Ethiopia. Greener indicates the higher NDVI value. So by clicking here, you can able to view the range value, that is it has a positive value, indicates there is a wetness, there is a higher wetness compared to other part of the study region, while red color here indicates the drier part of this region. You can able to view that. Then my negative indicates the lower NDVI value, that is lower NDVI also indicates the lower wetness value, so low soil moisture region. And also this part of the region has a higher NDVI value with higher moisture content. So in 2020 2012 January, we have a large part of the study area has a drier region compared to this part of this region, that is towards the south. We have a good NDVI value and also good soil moisture in this region. So in 2012 January, we have our drier or the low NDVI value here towards north, and also towards east and towards east. So on comparatively we have a good NDVI value towards south of Ethiopia. In the edge here, you can view that the greener portion indicates a good NDVI value, and red indicates the negative or a very low NDVI, indicating a drier in 2012 January. So basically, that's how you can able to check this NDVI anomaly for each of the month. That is variable chart equals to UI chart dot image dot series. The image collection we are referred by month, so we are referring it by our image collection. That is by month. So this is our by month. So it gives us the mean NDVI ranges in the chart. So we are region of our region is point. So initially we have created a point data. So this is our point data. So basically we are getting our data from this point data, and we are applying a reducer. So basically it gives us a mean value for each month, the mean value for each month. The scale, that is resolution. Scale refers to the resolution is around 500 meters, and property refers to that as our date. So we are given our date. So let me run this. Go to the option called run script. Click run script. Now go to the console section. So now you can able to view this is our chart. Let me zoom it. So now we are visualizing our NDVI anomaly for from 2012 to 2014, from 2000 to 2015. So what we're visualizing is a different NDVI anomaly that is being absorbed. So we can able to view that in 2012 there was significant drop in the NDVI value, which indicates there is a very low vegetation index and also low moisture. probably the absence of seasonal rainfall. And after some times towards 2013, that is towards September, there's a significant rise in the NDVI value, which indicates the increased vegetation. And also towards 2013, again January, there is a very a low, there is not a significant drop in vegetation compared to 2012, where there is a significant drop in the NDVI value. This is an anomaly. And also towards the 2013, we have our significant increase in the NDVI value. And also in 2014, we have a higher vegetation, that is vegetation index compared to other years, that is in 2012, 13, and 14. So using this data, we can able to see the different seasonal changes of our seasonal changes in the soil wetness or vegetation index, the vegetation index, using this option. So we can plot the NDVI values and see the different anomalies that is being observed for different years. So one part of the year, some part of the years had a significant drop, and compared to other regions where there is a higher vegetation index, high vegetation is observed. And also there is a significant increase in the wetness index in 2014 compared to that of 2012. There is a significant drop in our wetness index. So this time series plot will be very useful to understand the different activities, that is like the wetness, significant increase in wetness, and the dryness that can be observed in the different time series. That can be observed for different time series. So in this video, I have shown you how to. In this video, I have shown you how to create a point data, and how to import our world level country boundary layer, and how to perform the NDVI anomaly, and also how to plot the NDVI anomaly value as a chart, as a time series data, to observe the different seasonal effects during the drought and rainfall different drought that can be observed different part of the years. Thanks for watching. Please subscribe to our channel and give us a like.